Hello, class. I want to put a video on chapter 1 notes so that you can have, so you can use them for your work. Uh, Complex numbers, 1.3, they're what I call perfect squares, like the number 1, 4, 9, 16, 25, 36, and so on. These are numbers that when we take the square roots, they're perfect, like the square root of 16 is 4, square root of 25 is 5, etc. So that because 5 times 5 is 25, the square root of 25 is 5. Square root of 49 is 7 because 7 squared is 49. Obviously, that means a square root symbol. For non-perfect roots, we take numbers that are perfect squares that are factors of these numbers. Like 4 goes into 25 times. Square root of 4 is 2, so 2 square root of 5. Square root of 36 times 2, again, 36 divided into 72 twice. Square root of 36 is 6, so you get 6 square root of 2. For imaginary numbers, we're going to let the square root of negative 1 equals this imaginary letter I. So I squared is equal to negative 1, as is because of here. Square root of 25 is 5 because 5 squared is 25. Square root of negative 1 is I because I squared is negative 1. And so to simplify a negative, square root of a negative 36 is negative 1 times 36. Square root of negative 1 is I, so essentially I comes out. This becomes positive 36. Its square root is perfect, so 6I. And again, the same thing with number 2. 121 is perfect, but because it's negative there, we say it's negative 1 times 121. So the moral of the story is when you say negative side of a root, it essentially becomes I. Square root of 121 is 11, so 11I. Now 45 is not perfect, but 9 divides it essentially 5 times. Square root of 9 is 3. The negative in there really is negative 1, so the negative becomes I. 3 squared of 5 is what becomes a 45. And then 60 here, negative, essentially that should be letter D, not letter B. Okay, and so this becomes 2I squared of 15 because 4 times 15 is equal to 60 and 4 is perfect. Complex numbers can be written as A plus or minus BI, or A plus BI in this case. To add or subtract complex numbers, essentially what you're doing is you're combining the real part. Again, the real part is the number that has no I, and the imaginary part is the part that has I. So pretty much combine like terms. You add the part that's real, you add the part that's complex. So 3I plus 6I. Jeez. 3I plus 6I is not 8I, it is 9I. Okay? So 3 plus 6 is not 8, it's 9. Now subtraction, you have to be careful here. Instead of combining like terms right away, you have to distribute the negative first. So this becomes minus 6 plus 2I. So combine the numbers here. 4 minus 6 is negative 2. Negative 5I plus 2I is negative 3I. Multiplication, you're foiling. So 2 times 3 is 6. 2 times negative 4I is negative 8I. Negative 5I times 3 is 15I. 5I times negative 4I is negative 20I squared. But I squared is negative 1. So negative 1 times a negative 20 is a positive 20. These two guys in the middle become 7I. And 6 plus 20 is 26. A second example here, if I may. I'll move this real quick. 5 times 4 is 20. 5 times 3I is 15I. Negative 8I times 4 is negative 32I. And negative 8I times 3 is negative 24I squared. But again, I squared is negative 1. Negative 1 times negative 24 is positive 24. 24 plus 20 combined will be 44. 15I minus 32I is a negative 17I. Division. Whenever you're dividing by imaginary number, you have to multiply by the conjugate of the bottom. So this is minus 4 minus 5I, so we use 4 plus 5I. So when you multiply everything on top, you get 2 plus 23I. When you multiply everything on the bottom, the reason we use the conjugate is because the two numbers on the inside cancel. Here, negative 1 becomes I squared. I squared becomes negative 1. This becomes plus 25. So the 16 and the 25 just get added on the bottom. There's no more I. So you get 2 plus 23 over 41. 2 plus 23I over 41, which is 2 over 21 plus 23. 2 over 41 plus 23 over 41I. Same thing for letter F. You multiply it by the bottom, the conjugate of the bottom. This is 5 plus 6I. So you multiply by 5 minus 6I. You FOIL the top, you FOIL the bottom, you simplify. The bottom becomes 61. The top becomes 2 minus 39I. Again, 20 minus 18, negative 24 minus 15. And here you can separate it into two fractions, 2 over 61 minus 39 over 61i. And that's essentially 1.3. 1.4, quadratic equations. First and foremost, you have the square root property. This thing says you square root both sides to cancel the second power. So that's what the first three examples are. So in the first one, I subtract 49 from both sides and I get x squared equals negative 49. But now I square root both sides to cancel. So the square root property says when you square root both sides, you have a plus or minus answer. You have two possible answers. Here, when I square both sides, I get plus or minus 4. But because these are two integers, you have to respect both of them. So one equation is equal to positive 4, one equation is equal to negative 4. I add 8 to both sides in both equations, I get 12 for the first answer, 4 for the second answer. In this one, I subtract 20 from both sides. I take the square root of both sides to cancel with the power of 2. Now 20 is not, well, the negative becomes I. 20 is not perfect, so it becomes 4 times 5. The square root of 4 is 2, so 2i square root of 5. Then I move the 2 over by subtraction. Then I divide both sides by 3. Now these two cannot combine, so I just write them next to each other. Negative 2 first, plus or minus the other stuff it already has. 2i square root of 5. And I put all that over 3, and that's my final answer. Factoring, ultimately, these two numbers, again, you have to set equal to 0. Essentially, ax squared plus bx plus c equals to 0. That's a quadratic equation where a is not 0 and these are coefficients. So negative 4 times negative 2 is positive 8. Negative 4 minus minus 2 is equal to negative 6. So these two added up, negative 4 and a negative 2 added becomes negative 6. When you multiply, you get positive 8. So that's where the factoring comes in. Set them equal to 0. That's what the zero factor property says. And so you solve the first one by adding 4 to both sides. Solve the second one by adding 2 to both sides. You get 4 and 2 respectively. And now here, what two numbers multiply to be negative 6 and add up to be a negative 5? So negative 6 times a positive 1 is negative 6. Negative 6 plus 1 is negative 5. So you set them each equal to 0, and you get your two answers. For number 3, you have to move everything to the left first, essentially, to get a 0 on one side. So you say what two numbers multiply to be 2 in this x squared? So 2x squared. These two numbers, negative 1 times 3, give you negative 3. So that's why I chose those two. Now, if you multiply in the middle, the inner and the outer, this gives you positive 6x. This gives you negative 1x. So 6x minus 1x is your 5x in the middle. And so you set each of them equals to 0. This one you add 1 to both sides, divide both sides by 2. This one you add 3, subtract 3 from both sides. This one, 3 times 2 is your 6, so you get 6x squared by taking 3x times 2x. 2 times 1 is 2. In the middle, again, that's where you get the third number. These two numbers have to multiply to the last number. These two have to multiply with the first number. In such a way, when you multiply in the middle, 2 times 2x is 4x. 3x times 1 is 3x. 3x plus 4x gives you 7x. In such a way, you get 7 in the middle. Set them each equal to 0, and essentially you solve. That is the zero factor property. Completing the square, it's essentially half of the middle. You need to make sure that the number 7 here is negative 7 is on the other side. So we added 7 on both sides. And now we take half of the 4 in front of x. Half of 4 is 2. 2 to the second power is 4. This number 4 is a number we add to both sides because we have to be fair to both sides. We have to balance the equation. So this left-hand side will factor. Now, not only will it factor, but it will factor into the same parentheses twice. Because 2 times 2 is 4, but 2 plus 2 is also 4. So because there's 2 of them, it becomes x plus 2 squared. This adds up to negative 3. When you take the square root of both sides, you have a square root of a negative. So you have plus or minus, but the square root of a negative is I. Then subtract 2 from both sides, and you cannot combine this any further, so it's just negative 2 plus or minus I square root of 3. Sorry for the scribbling here, but in the second one, x squared minus 10x equals 25. You want to make sure the number has no x's on the right, which is good. If you take half of the middle, half of this negative 10 thing, half of negative 10 is negative 5, then you square it. That's positive 25. That's what you add to both sides. The left side will factor into x minus 5 twice, which becomes x minus 5 squared. The right becomes 50. And you take the square root of both sides. 50 is really 25 times 2. The square root of 25 is 5. And then add 5 to both sides. This doesn't become 10 square root of 2. It becomes 5 plus or minus 5 square root of 2. I just want to give you just a quick summary, a quick introduction to 1.4. Now, for 1.5, I didn't do too much of it. I just want to kind of ease you into it. it talks about little word problems. So it talks about right triangles, and it talks a little bit about consecutive integers that are like that are just added up to be squared. So if it says the sum of the squares of two consecutive odd integers is 202, the consecutive odd integers represented are 1, 3, 5, 7, 9, 11, 13, -1, -3, -5, so on. So you have two numbers, because they're odd, are separated by a distance of 2. So the first number will be x, if we don't know what it is. The second number will be x plus 2. If you want a third one, it'll be 2 more, which is x plus 4, x plus 6, x plus 8, and so on and so forth. But this only asks for 2. So the sum means two things added. The sum of the squares means two powers, two second powers. The first one is squared x squared. The second one is x plus 2 squared. So the sum of these two squares is 202. That's where I get the is equals, and then 202 is what it equals to. So if you multiply all this, if you again, this is x plus 2 squared, which is two parentheses of x plus 2, which is x squared plus 4x plus 4 when you simplify it. Combining like terms, you get 2x squared plus 4x plus 4. Then you move the 4 over, you get 198. I'm sorry. Well, I guess I could have just moved the 202 back this way, but I did an extra step here I shouldn't have. But I subtracted 4 from both sides, and I brought the 188 over by subtracting back. And I divide everything by 2 because they're all even numbers to kind of cancel the 2's out, and there's a 0 there. So x squared plus 2x minus 99 equals 0. Two numbers that multiply to negative 99, yet add up to be a positive 2 are a positive 11 and a negative 9. When you set each of them equal to 0 and you solve, the first one you get negative 11, the second one you get positive 9. If they're consecutive, the next one to the right essentially would be negative 9. Not positive 9 there, it would be negative 9. And the other one would be 9, the next one to the right would be 11. So as you're going left to right, the first pair would be negative 11 and negative 9. Second pair would be 9 and 11. I think on the My Math Lab, I'm just going to have you just set up the problem just to kind of get the feel for it. This one gives you parts of a right triangle, and it says set up an equation. So a squared plus b squared equals c squared. So x squared plus 2x minus 2 squared equals x plus 1 plus 4 squared. And that's all I really want you to do with that. It's going to get the feel for it here. The same thing for number 3. It wants us to get an expression for the missing side. Well, if this is a squared plus b squared equals c squared, it's r and s. R squared plus s squared equals to the essentially whatever this is, the hypotenuse squared. So to find the hypotenuse, it would just be the square root of both, a square root of these two guys added. And so the missing part would be the square root of r squared plus s squared. Just want you to kind of understand about Pythagorean theorem. Just kind of walk through the right triangles there. And now quadratic type, there are two types. There are essentially fractions, and there are also square roots. So, as it is, if I take this fractions and I subtract them, you tend to take what's called a least common denominator. So they have a 3 on the bottom and x minus 1 on the bottom. So least common multiple, or least common denominator would be the product of those two things. So I'm going to take the product of those two things and I'm going to distribute to all three pieces. If I do it correctly here, the 3 will cancel with this 3, and I'll have two parentheses of which I multiplied out here. If I take x minus the 3 times x minus 1 here to the second one, the x minus 1's cancel, so I just have the 3 times the 2x, or essentially 6x, or minus 6x. Here I have 3 times x minus 1, so I distribute it, and I get all of this. So then I take what looks the same, I combine like terms. The 3x squared has no partner. Negative x minus 3x minus 6x, that's a negative 10x, and then plus 1. So what I try to do is get the x squareds together. I try to get everything to the left. So I subtract 3x squared, but the x squareds cancel. I add, essentially, I add 10x to the right, and so I get 7x on the right and then 1 on the left. So I get x by itself. Then I divide both sides by 7, so x equals to 1 over 7. You got to be careful. The answers you get, make sure that when you plug back in for x, don't make the bottom 0. So the only one that's going to screw that up is a positive 1. This is not positive 1, it's 1 over 7, so it has an answer. Not so fortunate in the second one. In the second one, I have x squared minus 9 as one of the denominators. But that is a difference of squares. So x minus 3x plus 3, because negative 3 times positive 3 is negative 9. Negative 3 plus 3 is 0 in the middle. So it multiplies to be all this. So I know it's kind of small here, but x minus 3 and x plus 3 are the two different kind of parentheses that are here. So I'm going to multiply those sets of parentheses to both sides. In doing so, this will cancel, and I'll have an extra x plus 3, because this one will cancel with this one. So I have x plus 3 with a negative 2, and then x plus 3 will cancel with this one, leaving with an x minus 3. On the right, these two parentheses will cancel with these two parentheses. It's all gone. You just have negative 12. Distributing and combining like terms, I get x minus 15 equals to negative 12. I add 15 on both sides, I get x equals 3. It's kind of small here, but x equals 3 makes the denominator of at least one fraction equal to 0. So if I plug in a 3 there and a 3 there, I get zeros on the bottom, which cannot happen, which means no solution. And that's what this is saying. And then one more problem with the fractions. For this one, you essentially have to factor all three of them. So I get on the first one x plus 3x minus 2 because they multiply to be 3 and 2, negative 2 make negative 6. And they have to be a positive 1 in the middle. Here, positive 2 and negative 2 multiply by negative 4 and add up to a 0 in the middle. Here, 3 times 2 is 6, and the middle add up to 5. So I have 3, even though I have about 6 parentheses, I have 3 different types of parentheses. So those 3 represent the LCD. And so I multiply all 3 to each piece. 2 of them are going to cancel with these 2, and I'm going to be left with 1 survivor. 2 of them are going to cancel with this one, and I'm going to be left with 1 survivor. 2 of them are going to cancel with this one, and I'm going to be left with 1 survivor. So I distribute and get essentially x is but x to the left, number to the right, I get x equals negative 9. Because this number does not make the bottom 0 in any of these, it's a good answer. The second part essentially is the idea of square roots. So this one says a square root of x minus 10 is equal to 0. Add 10 on both sides. But to cancel a square root, you don't bring another square root, you take a second power. So 10 to the second power is 100, and that's all it is. Now you go back and normally just check to make sure it works out. I'm just showing you that check there. You don't have to, but just to be safe. Because sometimes it doesn't work. And my math lab is very picky on this. So in the next problem, you have to move the square root to the other side so you can have them separate. When you square both sides, you get rid of the square root, but this is the second power. So you bring everything back to the left. You subtract, you add by 2x and subtract by 15. On the left, then you try to factor. 5 times negative 3 is negative 15, and 5 minus 3 is positive 2. So you factor this way, you get 2 answers. Notice that one answer doesn't work, but one answer does. So x equals 3 is the answer. And if you put both answers, normally if we were in a class and I would grade your test in person, I'm okay with either one, but I think my math lab only going to accept this one. Just be careful. Or whatever software we're using at the time. And 1.7 and 1.8, there's the last part of this. It says there are inequalities. You're less than, you're greater than. So this is red. 3x plus 5 is greater than. Again, the mouth wants to eat the bigger part. So in this case, number 1, the left part is greater than the right part, or equal. So what you're trying to do is get x by itself. Typically, you want to get x to the left. So we subtract by 7x to get negative 4x. You subtract by 5, you get a positive 3. Now, the inequality stays the same. The only time the inequality symbol switches, as you can see in this problem here, is when you divide or multiply both sides by a negative number, which is what I'm saying here. So because you're dividing both sides by negative, the inequality will switch directions. And so this is red. If you read it from left to right, it says x is less than or equal to negative 3/4. And so when you write the interval, you're taking everything from the left side of the negative side of the negative 3/4, negative infinity, comma, all the way to the negative 3/4. Because you're including 3/4, you get a bracket. When you shade it, you're shading everything on the number line to the left of this number, and then you put a little bracket where you include them. So bracket means you're equals. Here, the left side is greater than the right. As you distribute the 3, distribute the 4, you combine like terms on the left and right, move the x to the left, move the number to the right. Because there's no dividing or multiplying by negative, the inequality stays the same direction. And so ultimately, x is greater than negative 5. Which means now, essentially, as it is, the greater stuff is this way. The greater stuff is this way, but the arrow kind of points to which way you're going to shade. So it's to the right of negative 5. There's a parenthesis because there's no equals. if you put inequality in between, again, this is called the interval solution, the solution to the problem. This is called the solution to the inequality. This is called interval notation, where you put a comma between two things and show that that's where the answer lives. And this is the shading, which is called the graphical solution. So now, if you have x in the middle of two inequalities, that's a compound inequality. Your goal is to do the same thing to all three sides so that x is left by itself in the middle. So take away 5 to all three sides. X lives in between -7 and -2. That's why I shade in between them. And so the interval goes from -7 on the left all the way to 2 on the right, with a bracket on the right, parentheses on the left because it's not equal on the left, equal on the right. For this one, I multiply all three pieces by 3, cancel the fraction. Then I add 1 to all three sides, then I divide all three sides by 2. Because I'm multiplying and dividing by positives and not negatives, I leave the inequalities the same. So this means that x lives between 8 and 14, which means I shade in between them, but I put bracket to indicate that it equals both of them. And as go a little bit here further, absolute value. If the absolute value is less than a positive number, then you take out the absolute value bars and you put this stuff in the middle. And you solve this inequality like the previous two problems. You add 1 to all three sides, get x by itself in the middle. So x is between -7/2 and +9/2. That's why they're shading in the middle. If it's greater than, you're on the outside. You're on the outside looking in. So you have two tails. So you're either greater than the positive version or you're less than the negative version. When you solve each inequality, you get x is less than -1, you get x is greater than 9. To the left of -1, to the right of 9, hence two shaded areas, two intervals. The first picture on the left is from -infinity up to -1, then you stop. So you put a union, you start again at 9 to infinity, all parentheses. And then this one is a second power. So second power quadratic, you try to use factoring. So you try to move everything to the left and factor everything you can here. Because it's x squared minus 5x minus 6, -6 times +1 is -6. In the middle, they add up to -5, so this is your factorization. So you set them equal to 0, and you get -6, and you get essentially a +1. Sorry, a +6 and a -1. So you put those numbers here, those are your critical points. Then you pick numbers in between here that I circled here. You put those numbers in here and to see if the original inequality is true or false. If it's true, you shade it. If it's false, you don't. It turns out that 2 of the 3 places are shaded. So my answer goes from -infinity up to -1. What's called a union between two intervals, 9 up to infinity. And that's where I'm getting these answers. And that's just in a nutshell what the chapter looks like. Just wanted to give you like a brief overview. Okay, so hopefully this will help you.